We are all using AI assistant system like Claude or ChatGPT on a daily day-to-day basis. Whenever we start typing any messages into these systems, we are triggering 10 to 15 services in the backend. 3 to 4 databases, cache layer, API systems, GPUs will be running behind the scene, all running together in a milliseconds. They start orchestrating together and generating this output. And well-designed architecture is running behind these kind of systems. By the end of this video, you'll be able to understand the complete architecture of any kind of AI assistant system like ChatGPT or this Claude. Let's go ahead and see the architecture component. I'm going to divide them into 6 to 7 layers. The first layer, it is called client layer. Client layer. From the client layer, we have this edge layer. From the edge layer, it will go to the third step, that is called the application layer. From the application layer, in the fourth stage, we have this orchestration layer. Fourth layer, we have this orchestration layer. And the fifth layer is called the AI layer. And the sixth layer, we can call it as data layer. And finally, we have the seventh layer. We can call it as scalability. These are the 7 layers of architecture which comes into picture when we consider about any of this AI assistant system like ChatGPT, Claude, Gemini, etc. Let's go ahead and see one by one each component. What are the functionalities they provide on each layer and how it is contributing to the overall architecture of this kind of system. Okay. This is the client layer. Client layer is the front end of the application. Okay, client will send the request and receive the response through this client layer. Okay, all the interaction happened through this layer. If you see this diagram, this is the first step. This client will send the request to this application. This is the first layer. The next layer, it is called the edge layer. Let's go ahead and see what are the components involved in this edge layer. Security, authentication, and authorization. Okay, all these kind of activities are checking here. Then come to load balancing, then CDN, content delivery network, CDN, CDN for caching. And this edge layer is helping us to do smooth communication between the client and the backend. So these are the important services or important activities happening in this edge layer: the security, the authentication and authorization, and load balancing, content delivery network, and the smooth communication between the client and the backend. When come to authentication, okay, if you see about this authentication, the moment you log in at the moment you log in, the system will provide a token. It is called JWT token, a short living token plus a refreshing token. And using this refreshing token, the session can be managed, and whenever they're requesting a new request, they can use this refreshing token to refresh their connectivity and move further forward. This is what is happening in this authentication layer. In the authorization layer, it will check the rate limiting In authorization, in the authorization layer, it is checking the rate limiting. These are the things which is happening in this authorization layer. Content delivery network. It is used for caching. It can be hit or miss. The content delivery concept we have already discussed in the previous videos, how it is happening and what is meant by this cache hit and cache miss, etc. Okay, these are the activities happening in this edge layer. If you see in this diagram, in the edge layer, we have this API gateway is there, and also we have the authentication. Authentication, it is doing the token validation and all, and the API gateway is doing the rate limiting and routing, etc. And all the services are being monitored. Okay, monitored in the sense it will do this legacy, so latency and error, and all those things are being monitored in this edge device or edge layer. Then go ahead and see the third step, that is called the application layer. The third one we call it as application layer. Third one we call it as the application layer. Let's see what are the functionalities, so what are the components involved in this application layer and what are they doing in this application layer. The application layer is where the core business logic is running. This is where the core business logic is running. Core business logic is running. Okay, it will process the request, or it will process the request, connect API, and it will do the coordination. Actually, it is working as an intersection between the AI layer and the API layer. It is working as the interface or intersection between API layer and a layer. Previous before that, we have discussed about this API layer here, API gateway, something, API gateway, authentication, monitoring, and all. Once the user is authenticated and the tokens are validated, then it will come to the application layer. In the application layer, that is where this core business logic is running. And this application layer acts as the interface between API layer and the AI layer. And what are the components involved in this application layer? We have the prompt builder will be there. Prompt builder. Why prompt builder? Because we are using this AI assistant platform to chat with the LLM model and generate some response. While creating any prompt, what are the components involved in this prompt builder? We have system prompt will be there. System prompt will be there. Along with that, we have chat history will be there. Chat history will be there. Along with that, user query. User query will be there. Using all these three, it will generate final prompt. Final. Even though if you have given only 4 or 5 words as a chat, it is not just the 5 words, it is going to go into the next stage. It will combine the system prompt, it will combine the chat history, and it will combine the user query along with that. All those components combined together, and it will create the final prompt. That is what it is going to pass to the next stage. Along with this prompt builder, we will be having chat services will be there. Chat services will be there. These are the two major components of this application layer. Okay, as discussed, these are the component of application layer. We have this prompt builder is here, we have the prompt builder combining the system prompt history and the user query, and we have this chat services. Chat services will handle this session management. Next, come to the orchestration layer. In this orchestration layer, it is going to do, or it is going to manage all the workflows, internal workflows it is going to manage. Then it will coordinate the multiple services together. It will coordinate the multiple services and ensure all the services run smoothly in the right sequence. All the services or all the involving services are run in the background smoothly. Right sequence. These are the components. These are the important mechanism running behind this orchestration layer. Okay, then what are the major components of this orchestration layer? Let's go ahead and see a few of them. In the orchestration layer, first thing comes into picture is a gateway. A gateway. A gateway in the sense we have already discussed this application layer. This application layer is the interface between API layer and the AI layer. Interface between API layer and the AI layer. API layer, we already discussed what are the activities happening in the API layer, just like monitoring, rate limiting, routing, and token validation, etc. Whereas when it comes to mm, the orchestration layer, where our first stage is AI gateway. What the AI gateway will do, it will do this model routing. It will do the model routing. Model routing in the sense always sending requests to the high-end model. It's not like that. Depend upon the request, what kind of request it is. Based on that request will be routed to the appropriate model. Not all the time it is not going to send the request to the same model or higher model. That depend upon our request. If it is something related to the math, it will go to that model which is proficient in math. If it is something to related to the long context, it will go to some model which is very good at handling the long context. If it is something related to multi-agent model, then or multi-model, then it will go to some models which is good at multi-modeling. Then another concept which is coming here, it is, let's see this diagram. The AI gateway, it will do this model routing, and then it will do the streaming. It will do the streaming. Streaming in the sense of server-side events, that is to keep alive monitoring of the chat systems and all. The model routing, it will do the LLM selection, large language model selection. This is what is happening in this orchestration layer. Then come to the fifth stage. It is going to be the most important stage in any of this AI assistant platform. That is called, this is going to be the brain of the system. Okay, so far what we have done, the user came into picture, they have sent some query, and in the second stage, that query will be passed to we'll do the authentication and authorization, then it will go to the API gateway. Then it will go to the orchestration layer and all. There we have this prompt. If you see the stage 3, edge layer, from the edge layer it come to the application layer. In the application layer, where we have something called the prompt builder. The prompt builder will combine the system query, user query, and the chat history. They combine together and create a final chat query. This is the um, We can call it as the response path, initial response path. Okay, this app layer will create the final query. This final query then will be passed through this AI gateway and to the appropriate model. It will route to the appropriate model, and then it will come to this AI layer. In the AI layer, what is going to happen? In the AI layer, what the first I would like to divide this AI layer into three stages. The first one is assemblies. The second one is transformer architecture. And the third one is output generation. Okay, let's go ahead and see one by one what are the first stage is input assembly. Okay, first stage is input assembly. As an input assembly, we have to give the input. Input we got from stage 3 or step 3, we have the prompt, final prompt. Final prompt is a combination of system prompt plus chat history, plus we have one more component that is called user query. This is what we call the input. This is what is called the input. This is what is called the input. This input prompt. This input will be given to the LLM system. We are going to go into the brain of the system. The first stage it will be doing is tokenization. Okay, tokenization means it will be converted into small tokens. Usually, if it is a ChatGPT, they are using byte pair encoding. Using the byte pair encoding, they will create IDs. This ID is called token ID. Okay, this is called token ID. Token ID. Token ID. Once it is tokenized, then it will be having token ID, and then it will go to the embedding stage. Embeddings. Here we have the tokens. Tokens will be converted into vectors. Okay, vectors. And along with the vectors, we'll be adding something called positional encoding. Positional encoding. Why positional encodings? The positional encoding will give the system that where this data reside in that particular sentence, whether it come before or after, where this particular token was placed in the original sentence, and it will give a semantic context of the system. Now we have created embeddings. This is the initial assembly phase. In the initial assembly phase, initially we have the input prompt. That is the combination of system prompt plus user query plus chat history. Then it will be tokenized into smart tokens and assigned with the token ID. Those token ID will be given to the embeddings. Here we will do the vectorization and position encoding will be added. And those embeddings will be then we will be generating the embeddings. Embeddings in the sense they are dense vectors. They are dense vectors. These are dense vectors of ones and zeros. These are these are dense vectors. Each word will be converted into vectors. And here we got the embrace. As the next stage, we'll be passing this output to the transformer architecture. We'll be transferring this data to the transformer architecture. The second stage is transformer architecture. Transformer architecture, it is encoder decoder based architecture. Behind the scene, what is happening is behind the scene is a lot of neural networks are working together. Neural network running behind the scene. In the transformer architecture, if you see, the input will be going through the series of component. Like first thing will be first it will go to the self attention mechanism. There we have query key v weights will be created. QKV weights will be created in the self attention mechanism. Then the self attention mechanism, the data will be passing through the next stage, that is called, once the QKV vectors are created, it will go to the feed forward network. It will go to the feed forward network. From the feed forward network, the data will be passed to layer normalization. And finally, it will create output embrace. Okay, this is what is happening inside this transformer architecture. It will go to the self-attention mechanism. It will create the QKV vector weights will be created. Then it will go to the feed-forward network. This is a non-linear transformation is happening. Then go to the layer normalization where we'll stabilize the gradients. And final output, that will be output embeddings. It will create the context vectors. And if you see here, from the input assembly to the transformer architecture, we are converting the embedding into context vectors. We are converting embedding into context vectors. From the in the AI layer, from the input assembly to the transformer architecture, what we are doing, we are converting embeddings into context vectors. Embeddings into context vectors. Now this context vectors will be given to token probabilities. We'll be passing through this token probability where we are using softmax activation function to find the vectors. We are using softmax activation functions. Okay. From the token probability, we will be predicting next token. We will identify the next token. Now we have the nearby tokens available. Token will have the token ID that is in the token format. Now we need to convert those tokens back into IDs. That is called detokenization. Detokenizer. What does it will do? It will be converting IDs, token IDs into text. token IDs into text format. Now this text will be fed into. Okay, now the flow is we have this context vectors are there. Then the context vectors will be given to the token probability. Using the softmax activation function, will be generating this next token. We'll be predicting the next token. Uh, then we have this token IDs available. These token IDs has to be converted into text format. So there initially we have used the tokenizers to convert the text into tokens. Now we are using detokenizer to convert the IDs into text. Here we'll do the detokenizer, and once it is detokenized, we have the output text available. Those output will be given to the output interface. Output interface in the means in the chat interface on a streaming way or on a batch mode. This is what is happening in the AI layer. Okay, this is what we have discussed so far. We have the combined prompt, which is coming from the layer 3. That is the combination of query, the user query, system prompt, and the chat history. These are the input tokens or input data. That input token will be converted into token. That is how we are using byte pair encoding to convert the tokens into IDs, token IDs. Then those data or token will be embedded. Embedded means we have the vector plus positional encoding to create the final embeddings. What we are doing is we are converting these embeddings into context vectors so that we can do the token probability check. How we are doing this one? We are doing this using this transformer architecture. In the transformer architecture, we have the self-attention layer is there. After the self-attention layer, we will be creating KQV ways will be created. Then that data will be given to the feed-forward network. It is a non-linear transformation will be done. Once it is out of the feed-forward network, we'll be doing the layer normalization, that is to stabilize the gradients. And once it is normalized, we will be getting output embeddings will be generated. Now these are called the context vectors are available. Using this context vectors, we are going to do the token probability. Using the softmax activation function, we'll do the token probability, and we will get for each token what is the probability value we will be getting. Based on that, highest probability value will be taking as the next word. That is called the next token will be identified. That is from the token probability, what is the highest probability weight that will be taken as the next problem. Once it is taken, we have a series of token IDs will be there. Those token IDs has to be converted into the text. Initially, we have converted text into token using tokenizer byte pair encoding we have used to do the conversion of text to IDs. Here we are doing the reverse process. We need to convert the token ID into corresponding text. We are using detokenizer. Once it is detokenized, we will be getting the text format that will be given at the output in the chat interface. This is what is the brain of the system, which is converting or generating the required output. Once it is done, the next layer is the layer 6, that is called the data layer. Or we have cache system like Redis, or we have for saving the vectors, we have vector database. Vector databases. These data are used for tracking purpose or traceability, token tracking, because tokens are always counted. We need to have a count of how many tokens are coming in and how many tokens are going out. We need to have a track of that. Okay, these are the things comes under this data layer. And databases will be the structured query languages like PostgreSQL, MySQL, or any of the databases will be there. Then caching layer, we have the Redis. Here, this Redis is used for caching, and VectorDB for rack pipeline and all, retrieval augmented generation and all. We are using vector databases, and we are using this data layer for token tracking and all. And finally, these are the components available or coming inside this data layer. One is the storage, that is for the chat history, documents, and all. Then we have the storage usage tracking, that is token, cost, and quota. These are all things will be tracked here. And finally, we have this vector database for the embeddings and RAG pipeline. These are the 6 layers of any of the AI assistant platform. Okay, seventh layer is scalability. When it comes to scalability, we should know where the system will bend and where the system will not bend. Okay, when it considering the scalability, if you see the API gateway, front end, authentication, chat services, prompt builder, these system we can do the scale out, but we need to take keen consideration about this GPU capacity. Okay, what we need to do is depend upon the usage. We need to route the request back to the appropriate LLM. For a small text generation, or we need to route the request back to the lower capacity LLM model so that it won't consume that much GPUs. Whereas when it need to consume more tokens or a system with more usage is required, then we need to consider about the high-end GPU models. Okay, you can spin more GPUs as GPUs than another containers. Okay, smart routing across models and providers is often bigger lever than buying more hardware. These are the major architecture components of any of this AI system platform. Let's go ahead and see all this component together in a single architecture diagram so that it will be very clear for every one of us. Let's go ahead and see this architecture all together. Initially, we have this client layer here. In the client layer, the user will come and ask the question. It will go to the edge layer where we have this API gateway or authentication. So then it will go to the monitoring services. Okay, in the edge gateway, we have this API gateways here. API gateway authentication monitoring is happening. The monitoring here, what it is doing, it will check the latency, error, and all. It will be monitored. In the app layer, what are the questions we have asked along with the system prompt and chat history, and the user it will create a combined prompt. Then one more layer, it is in this chat services. Um, this is the response path, we can say. This combined input will be given to the AI gateway. The AI gateway will identify to which model it was to route. Then, depend upon that usage, it will go to the particular model. Here we have this model route and streaming will be there. This streaming output will be given back to this client at this client layer. Once it is there, it is having the correct LLM. It know where to route this request is, and it is having the prompt. What prompt it is having? It is the from the step 3. There is a prompt builder has created the final prompt. It is having the final prompt is here. Now it is going to this application layer. Application layer, we have the 3 stages. One is input assembly is here. One is called the input assembly. After the input assembly, we have this transformer architecture, that is encoded decoder transformer architecture is there. Finally, we have this output decoding. In the input assembly, we have this query, system prompt, and chat history combined together to generate the input token that will be tokenized and converted into embeddings using the position encoding also. Once it is converted into embedding, that will be given to the next layer, that is the transformer architecture. In this transformer architecture, various components are involved, like self-attention mechanism. In the self-attention mechanism, it will create KQV weights that will be given to this next layer called the feed forward network. In the feed forward network, it will do the linear transformation of the vectors. Once it is linearly transformed, then it will given to the layer normalization. There we will do this gradient stabilization will do. Once it is done, we will get the final context vectors. We will receive the final context vectors. That context vectors will be given to the output encoding. In the next stage, what we are doing, we have this output context available, or output embedding as a context vectors available. We will do the token probability using the softmax vector, softmax activation function. Based on that, it will generate probability for each and every weight. Which word is having the most highest probability that will be a word will be considered as the next word. That next word will be taken, and like that, each word will be taken one by one. Each token will have a token ID. Initially, we have converted text into token. We have used the byte pair encoding to do this conversion to token. Now we have Now we have to convert them back to the test. Now we have the token ID. We have to detokenize them back to the test. Once it is detokenized, we have the text information that will be given as a output test. This is the overall architecture of AI layer. Once it is done, the AI layer, we have another two more layer which is happening behind, is running behind the scene. One is called the data layer, and another one is called the scalability. Data layer will have the different databases like PostgreSQL to save all the chat histories and all. Then we have the caching layer as Redis, and finally we have the vector database for the embeddings. On top of this, we have the scalability system. These are the major architecture components of any of the AI assistant platform. Um, Hope you have understood what are the major components and what it is done, how the process flow is happening from user query until we receive the first word in very milliseconds or seconds. These are the functionalities which is happening behind the scene in millisecond speed. So this is the full log from generating or from entering some question into the system to generating the response. If you see, we have asked some question into the client, then it will go to the API gateway. In the API gateway, it will do the authentication, authorization, and it will go to the chat services. From the chat services, it will go to the orchestration layer where we have the prompt builder and AI gateway is there. AI gateway will do to which model it was routed. This is called the model routing, and it is and the streaming services also. In the AI service itself, we have different layers to do this text generation, like self-attention mechanism, transformer architecture, embeddings, and context window generation, context vector generation, and finally output generation. That is output token generation using probability, and then we'll do the token probability. From the token probability, we'll find out the next token, and from the next token, we'll convert that next token back to the text format, that is converting token ID into text, then generating the output and displaying the output in the chat window. This is what the complete loop of this AI assistant platform, like you see in this schematic diagram flow. This is the complete flow of any AI assisted platform, how the system is working from user query to generating the response. This is all about this video. Hope you enjoy this one. See you in the next video with some upcoming interesting topic. Thanks for watching. Have a good day. Bye.